In this video, we're going to cover the first 5 definitions of Euclid Book 3. That's right, we have made it, folks, to Euclid Book 3, and we're going to cover the first 5 definitions in this video. And then I'm going to produce yet another video that will cover the remainder of the definitions. Okay, let's start with the first definition. If 2 circles are the same size, then the diameters in each one of those circles are going to be also the same size. Now, do you remember what a diameter is? That was taught in Euclid Book 1. I covered it again in Euclid Book 2. We're going to cover it again. The diameter of a circle is a line that goes from one edge of the circumference of the circle to the other edge of the circumference of the circle. Okay? And you should know this by now because I covered this both in Euclid Book 1 and Euclid Book 2. So, if you have 2 circles, and the diameter of one circle is exactly the same size as the diameter of another circle, then the 2 circles are going to be equal in size. Furthermore, if the radii of one circle is equal to the radii of another circle, and I could go on and say, well, if the radius of one circle is equal to the radius of another circle, then the 2 circles are exactly the same size. You should know this by Euclid Book 1 and Euclid Book 2. Alright. If you have a straight line and it meets the circle but it does not cut the circle, in other words, it doesn't chop the circle in half, then that line touches the circle. Okay. If you have 2 circles that come together, they meet at some point, but they don't cut each other, then those circles are touching each other. If the 2 circles cut each other, they're more than just touching, alright? Now, I want you to give me just a second here because I'm going to take this thing off my camera off the platform and show you definitions 4 and 5. Hang on. Now we're going to turn this, down here. As you can see here, we got a great big circle right across here. Okay, I know it's hard to see, but we got a great big circle, and you can follow my ink pen here. It's one giant circle right across here. Now in this case, I made the circle 2 inches in size, and I did this deliberately so that you could see what I was trying to do. Okay. Euclid says for definition number 4 that these 2 these 2 lines here, now we have a line here and it's from C to D, okay, from C to D. As you'll notice, this line touches at C, it also touches at D, so it's touching the circumference at 2 spots. We have another line over here and it's F to G. Again, this line touches the circumference of the circle at point F and also at point G. Now, because point A, now you see point A here, that's the center of this great big circle. Because AE and AH are equal in size, AE and AH just happen to be the perpendiculars of CD and FG. Let me say that again. AE is the perpendicular of CD. And you know what I mean by that, because if you don't, you need to go back to Euclid Book 1. It also happens that AH is also the perpendicular of FG. And since AE and AH in this case are equal, and Euclid says so, then line CD and line FG are equally as far away from point A as the other. In other words, CD is as far away from point A as FG is. FG is a certain distance from A, and so is CD. Okay? Now, Euclid says in definition 5, in definition 5 of Euclid Book 3, he says, because AM is longer in size than AH or AE, then KL is further away from point A than CD or FG. Okay? AM is longer in size, AM is longer in size than AH or AE. So therefore, line KL, which touches the circle at point K and touches the circle again at point L but doesn't cut it, okay? KL is further away from point A than line CD or FG. And that is Euclid's definitions 1 through 5 from Book 3. I will tell you more in a future video, so stay tuned.